Okay. Bye-bye. Okay. Okay, bye-bye. 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 Okay, all right. So we're doing solving quadratics by factoring. Yay. Okay. Anyways. All right. This section is on factoring, factoring, factoring. This is a topic that will be with you for your rest of your high school math career. It does not go away. It does not go away. All right, zero property of multiplication. Oops. What does this have to do with factoring? Well, what is the zero property of multiplication? Why is factoring important? Because of this property. All right, so here we have a times b equals 0. What do you know about a or b? You know that one of them has to be 0. If you have a times b equals 0, you know that one of them, a or b, must be 0. What if I had a times b equals 3? Well, it could be 3 and 1. It could be 6 and 1/2. It could be 9 and 1/3. There are no restrictions on a or b. This is why we're going to set it equal to 0 and 2 because I lost track. That's why factoring is important. Once we get two things multiplied together set equal to 0, we know what one of them has to be. And this is not limited to 2 factors. This could be like 6 different factors multiplied together make equal 0. That means all 6 factors because it could be 0, right? If I had 6 factors, 20 factors, whatever. If I have factors multiplied together to equal 0, one of them has to be 0. Okay, so that's what we're going to count on. Okay, all right. So whenever we have an equation with an exponent higher than 1, right? Whenever exponent is higher than 1, we're going to move everything to one side and set equal to 0, and then factor, kind of like this one, right? So here we have an exponent of 2. We're going to move this stuff to the left and get that. And this is something that's factorable, and that's what this lesson is about: getting this thing, factor it, so we can use the zero property of multiplication and set each factor equal to 0. Okay. So, the easy one. This is the easy one people understand to begin with, and then they forget about this one. I don't know why. Here, what we're going to do is find two terms, right? There's just two terms, and each of these terms have something in common. So in this example, there's a common factor of x. What we're going to do is factor it out. When we factor it out, we are undistributing. Remember the distributive property? I have noticed that everyone knows the distributive property. We're doing the distributive property backwards. We're taking the x out, right? So here, I'm taking an x out. Basically, when you factor something out, you're dividing by it. So x squared divided by x. If you remember your properties of exponents from algebra 1, you're subtracting the exponent. So 2 minus 1 is 1, right? Remember, if you don't see an exponent, it's 1. So when I take x out of x squared, it leaves an x, right? X to the second divided by x to the first is x to the first. That's where that x is coming from. When I take an x out of 3x, it leaves just a 3. That's it. So this is now in factored form. It's x times x plus 3. Okay? Since it's in factored form, that means one of them has to be a 0. I'm sorry. Factored form equal to 0 makes it so that one of them has to be 0. So that means x equals 0 or x minus 3 equals 0. That means x equals 0 or x equals 3. So these numbers make the original equation true. So if I plug 0 into this expression, 0 squared minus 3 times 0, right? 3 times 0 is 0. 0 minus 0 is 0. So that's it. Plug 3 in there. 3 squared is 9 minus 3 times 3 is 9. 9 minus 9 is 0. That's it. So these two are the answers to the original quadratic. Example 2. Here, what's the common factor here? Well, 2 goes into both of those, right? 6 is divisible by 2. 2 is divisible by 2. And there's also a common factor of x. So we take it out, right? So here, the 3x comes from doing 6x squared divided by 2x. 6 divided by 2 is 3. X squared divided by x is x. 2x divided by 2x is 1. Okay. So now we have it in factored form equal to 0. That means each factor can equal 0. So 2x equals 0 or 3x minus 1 equals 0. Okay. By the way, for those of you who like to do mental math, if you skip this step, I'm okay with that, as long as you get the correct answer, right? So here, I think most people get this correct, x equals 0. This is where people screw it up, right? They can't do this mental math very well. And if you make a mistake one time, that means you got to do it by hand every time, okay? So you add 1 to both sides, divide by 3. That's how we get x equals 1/3. Okay. All right, next example. So here, this is not equal to 0 this time, but we're going to have to make it equal to 0. So we're going to move the x to the left. When I move the x to the left, that's going to be minus 6x. When I move the minus 3x squared to the left, that's going to be plus 3x, making it 9x squared. So it's 9x squared minus 6x. Once it's equal to 0, we can go ahead and factor. So what's the common factor this time? The common factor this time is 3x, right? 3 goes into 9, and 3 goes into 6. X goes into x squared, and x goes into x, obviously. Take that out. So 9 divided by 3 is 3. X squared divided by x is x. 6 divided by 3 is 2. X divided by x is 1, so there's no x left over. Now we have factored form equal to 0. So that means each factor is equal to 0. So 3x equals 0, or 3x minus 2 equals 0. Solve that for x. Solve each of them for x. And you get x equals 0, and x equals 2/3. Yes, mental math. If you skip this step, it's okay, as long as you don't get this fraction wrong. All right, I think that's the last one of that. All right, quadratic trinomial. So we've had binomials with a common factor. Now we have the trinomial. This is going to be the most common type of problem. It's going to be trinomial. There's going to be nothing in the front, but this is a whole new level. All right. But this is going to be everybody's favorite problem. Now, this is something you can use this thing. This little X here is going to help you organize the information. If you don't do it this way, I am perfectly okay. But this will help you get things started. So what we're going to look at, we're going to take the 8. See, the 8 here. We'll put it up top. We're going to take the 6, and we're going to put it on the bottom. Now, this is like a puzzle to be solved. What times what equals 8? That combine to make 6. So that's going to be 8 times 1. What's 8 times 1? 8 times 1 is 8. Is 8 plus 1 6? No, 8 plus 1 is 9. So that's no good. So let's try different numbers. How about 2 times 4? 2 times 4 is 8. 2 plus 4 is 6. So that's going to be our factors. Now, what are we talking about? Well, it looks like this. A trinomial factored becomes 2 binomials. Right? X squared becomes x and x, right? X times x is x squared. The 8 comes from 2 times 4. 2 times 4 is 8. So where does a 6 come from? If you remember how to multiply binomials from Algebra 1, yes, that's 2 years ago. X times x is x squared. So, but x times 4, right? This is multiplying 2 binomials. 4 times x is 4x. And then 2 times x is 2x. So you add those two. 4x plus 2x gives me 6x. So that's where that 6 is come from. And then, of course, 2 times 4 is 8. So this is taking the, some teachers call it foiling. I call it double distribution because you distribute it twice. Distribute x twice, distribute the 2 twice. Okay? But FOIL is a very common name for what we just did, right? To get back to the original. You multiply these 2 binomials to get this trinomial. That's foiling, or just multiplication. Okay, all right. So now that we have it in factored form, we can solve it. X plus 2 equals 0, x plus 4 equals 0. That means x is negative 2, x is negative 4. All right, let's just confirm that this is the answer. That means you plug negative 2 back into the original. Negative 2 squared is positive 4. Negative 2 times 6 is negative 12. 4 minus 12 is negative 8. Negative 8 plus 8 is 0. So that worked. Let's try negative 4. Negative 4 squared is positive 16. 6 times negative 4 is negative 24. 16 minus 24 is, guess what? Negative 8. Negative 8 plus 8 makes 0. All right, so I'm not going to do that for every problem. I just want to show you that you're going to plug in that if you get a solution, that means that value replaces all the x values, not like one for this one and one for the other one. But that one is for both of them, and that one is for both of them. Okay? All right, this example. So the difference between the last example and this one, this has a negative sign. We're still going to set up the little x. This just organizes the information. If you don't want to do it this way, that's perfectly fine. But the 8 goes to the top, and and then negative 6 goes to the bottom. So now we want a negative 6. So 8 times 1 equals 8, but 8 plus 1 is 9. It's still not negative 6. And what about 2 and 4? Whoa, 2 times 4 is 8, but 2 plus 4 is positive 6, not negative 6. What about negative 2? Well, negative 2 times 4 is not positive 8. Negative 2 times 4 is negative 8, so that doesn't work. So that means both of them have to be negative. Negative 2 times negative 4 is positive 8. Negative 2 plus negative 4 is negative 6. So that works. All right. So then our factors are x minus 2 times x minus 4 equals 0. Set each factor equal to 0, and we get x equals 2 or x equals 4. And that's it. Okay. Oh, here's another example. All right. We got something else. So this time, the last times, the last term was positive. This time the last term is negative. So here we go. We're going to put the negative 8 up top, positive 2 on the bottom. And so to get a negative number up here, you have to have one negative, one positive. So negative 8 times 1 is negative 8. What's negative 8 plus 1? Well, it's negative 7, not 2. So that's not going to work. Let's try something else. How about negative 4 times 2? Negative 4 times 2 is negative 8. Negative 4 plus 2 is negative 2. So that doesn't work. But it's close. We just have the wrong sign. So that means just swap the signs, right? Take the negative 4, make it positive. Take the positive 2, make it negative. 4 times negative 2 is still negative 8. 4 plus negative 2 is positive 2. So that is our combination. All right. So we make x plus 4 and x minus 2. Set each factor equal to 0. And we get the answer x equals negative 4 or x equals 2. Okay. Is there another? Okay. So here we go. So this time, it is not set equal to 0 for you. So that means you got to move everything so that it is equal to 0. So I'm going to move the 5x squared to the left. That's going to make it 4 minus 5, make it negative x squared. I'm going to add 4x, making it plus x, right? Negative 3 plus 4 is going to be positive 1, so it's plus x. Bring the minus 6 to the left, and that becomes plus 6. And that's what we got, right? 4 minus 5 is negative 1. Negative 3 plus 4 is positive 1. Negative 6 becomes positive 6 on the left-hand side. Now, look at the title, Quadratic Trinomial with Leading Coefficient of 1. Not negative 1, but 1. So that means I got to get rid of this negative. And by the way, even when you learn the advanced techniques, you don't want that negative in front. That just makes things worse. It's much more difficult. It's hard to get your head around it. You can do it, but it's not fun. All right. Not that I'm claiming that any of this is fun. But anyway. Oh, so that means what I'm going to do is change all the signs. So the negative becomes positive, the positive become minuses, and it looks like that. Now we can factor it. So here we're going to look at the factors of 6 or negative 6 that combine to make negative 1. That's right. It's x minus 3 and x plus 2, right? Negative 3 times 2 is negative 6. Negative 3 plus 2 is negative 1. That's it. Set each factor equal to 0, and you have a solution. X equals 3 or x equals negative 2. There we go. That's it. Okay. That's the last example. More in the next video. All of these have been leading coefficient of 1. So next one, we're going to have a quadratic trinomial with leading coefficient of greater than 1. But prime. And you probably don't care about whether it's prime or composite, or maybe you don't even remember what prime or composite is. But anyways, that's going to be a next video. This has been plenty long. Okay. Good night. Bye-bye.